So, continuing our discussion of neuroblastoma, we'll begin with a review of the sympathetic and parasympathetic nervous systems. The neuroblastomas arise from the sympathetic nervous system, but I think in order to understand them it's useful to very briefly review both. So, with regard to the parasympathetic nervous system, its function is predominantly involved in housekeeping. So just regulating, the function of viscera so that it could be autonomic or automatic anyway, so that you don't have to concentrate, and therefore you could have contraction and maintenance and proper maintenance of the viscera and housekeeping within the body without divesting any conscious effort. So the autonomic nervous system always has a presynaptic neuron and a postsynaptic neuron. So the presynaptic neurons of the parasympathetic nervous system are housed in a craniosacral distribution. And so the cranial outflow is really right up here, and it's really the vagus nerve nucleus, and gives rise to the vagus nerve that then wanders throughout the body and supply the various viscera. And the sacral outflow really goes into the sacral plexus, straight from the spinal cord. So the presynaptic neuron in the parasympathetic nervous system is a central neuron within the brain or spinal cord. So this portion is presynaptic, and that's the first neuron. Then, subsequently, there's going to be a postsynaptic relay, or a postsynaptic neuron. And so, the presynaptic neuron relays on its target, and the neurotransmitter used at that synapse is acetylcholine. And then, you have a neuron, and I'll just, show some axons and dendrites. And they're arranged in clusters in the peripheral nervous system, in the autonomic nervous system, and these are called ganglia, and this will be a parasympathetic ganglia, and it's a postsynaptic parasympathetic ganglia. And so let's highlight that. So we'll show here that this cluster of cells is called a postsynaptic parasympathetic ganglia, and these neurons do talk to each other, but mainly what they do is that they release outflow, and the outflow is directly innervates the viscus, and I'll show that. And the neurotransmitter of the postsynaptic neuron is also acetylcholine. So you have a presynaptic fiber, or a presynaptic neuron, that uses acetylcholine as its neurotransmitter, and a postsynaptic neuron that uses acetylcholine. So they're both cholinergic, and that's a feature of the parasympathetic nervous system that's largely involved in housekeeping. Now the other characteristic feature, just to put it all together, of the parasympathetic nervous system is that the postsynaptic ganglia are located within the viscus themselves. So in the bladder, they're just ganglia within the bladder wall. Within the gut, they're quite elaborate, and they form a very, very elaborate network that we call the enteric nervous system. And one of the curious things about the enteric nervous system is that it's richer in the diversity of its postsynaptic neurotransmitters. And really, there's some plasticity here. So this usually is cholinergic, but there is some, play on what the body can use here. I mean, it's just really elaboration of various chemicals. So you could find serotonin, you could find dopaminergic neurons, and in fact we know that Parkinson's could affect the gut, and many other signatures, and these have been very, very well worked out. But the predominant, and of course nitric oxide, but a predominant neurotransmitter, the most predominant one, are the cholinergic. So just to recapitulate, for your housekeeping functions of the parasympathetic nervous system, you have your presynaptic neuron that's located within the central nervous system that sends a fiber to the ganglia that's located within the viscus. The ganglia are the collection of neurons, and these neurons then receive their input and input to the remainder of the organ, input to the organ itself, and both the presynaptic neurotransmitter and the postsynaptic neurotransmitter are cholinergic. But what I the one point, the one take-home message for this with regard to the parasympathetic nervous system, what's critical is to understand this structure, this postsynaptic ganglia. And, these are made, and it's very, very interesting, by a budding off of neurons embryologically from the neural crest that then come and populate the various viscera and create these ganglia that then become the parasympathetic ganglia. Now, these are not involved in neuroblastoma, but as an example, the migration of the neural crest to form these visceral ganglia can go wrong, and we see examples of that in Hirschsprung's disease. So that's the parasympathetic nervous system, and I only bring it up in the context of neuroblastoma as a comparator, just to compare and help you understand the sympathetic nervous system, which I'm going to address next. So this then brings us to the discussion of the sympathetic nervous system. So the sympathetic nervous system's outflow is actually what's called thoracolumbar. And so in the thoracic and lumbar portions of the spinal column is where you get your presynaptic outflow for the sympathetic nervous system. And the presynaptic neurotransmitter is, once again, acetylcholine. So it's presynaptic cholinergic neurons. In contrast to the parasympathetic nervous system, in the sympathetic nervous system, here are their ganglia again, and then let's say there's a little interneuron here, and here's their ganglia, and here's their ganglia, and truth be told, there's even Schwann cells between. And so here are their ganglia. In contrast to the parasympathetic nervous system, in the sympathetic nervous system, the ganglia are not situated in the target end organ, but they're actually situated in the paraspinal location. That's where the ganglia are located. And then they send their fibers out, and the fibers synapse on the target organ, but in a different way, because the purpose of the sympathetic nervous system is not to maintain the housekeeping of an organ, but rather to help in fight or flight response. So it'll mainly innervate things like erector pili muscle in the skin, and sweat glands, and blood vessels to redirect blood flow. So the kind of thing that would happen if one was running away from a bear. And the neurotransmitter used here is norepinephrine or noradrenaline. And that's what's used in the target organ. So these neurons themselves within the ganglia are norepinephrine producing neurons, or norepinephrine producing ganglion cells. The one additional comment is that there is also a specialized organ that's part of the sympathetic nervous system, and that's the adrenal gland. And we'll leave the adrenal cortex out because that's not involved. But the adrenal medulla is very, very important. And the adrenal medulla is sort of like a ganglia. It too receives input presynaptically. So it receives presynaptic input, just like the ganglia. But what's happening here is something a little bit different. What's happening within the adrenal cortex, within the adrenal medulla. So what's happening in here is that, so I'm just going to draw it up here. Instead of having a direct synapse from presynaptic neuron to postsynaptic neuron, imagine the synapse is coming in and it terminates on a cell called a pheochromocyte. It's a very specialized cell. And instead of the cell then sending off a second relay, what it does is it releases a hormone directly into the bloodstream. So imagine this is a blood vessel, and this is a hormone. And the hormone used is similar to norepinephrine, just slightly modified. It's epinephrine or adrenaline, norepinephrine or noradrenaline. And these cells are called pheochromocytes, and they're very, very, very similar. The adrenal medullary cells, the adrenal medullary cells, are very, very, very similar to the postsynaptic ganglia of the sympathetic nervous system. So once again, the ganglia, which we said are not in the target organ, and I'll show you exactly where they are, the ganglia of the sympathetic nervous system are very similar and are embryologically very, very similar to the adrenal medullary cells. So where these are located is if you could imagine, here are your spinal elements from your spinal cord sitting on top of your nervous system, sort of protecting and housing your nervous system. And we could even add in the facets. Look, the facets, and you could imagine here housing, and there's even you could imagine the posterior facets. And so here's your spinal cord running through, and all along, running up and down the spinal cord, this is the ganglia are situated. So just imagine the ganglia is actually here. The ganglia are situated all along the spinal column, and then lateral at the level of the kidneys, you have your adrenals. So all the way up and down the body, even beyond the thoracolumbar outflow, because there are some fibers that go up, and those are involved in situations like Horner syndrome, but we'll simplify for the sake of this discussion, and we won't get too carried away with that. But you have these ganglia that are situated up and down the body. If you look at the retroperitoneum along the spinal column, up and down the body, and then they send out the sympathetic fibers. And so the distribution of neuroblastoma follows the distribution of the sympathetic ganglia and also the adrenal medulla. And some of these ganglia also track along vessels, so that they could track along the iliacs. You also see them along the iliacs, and that's the organ of Zuckerkandl. So the distribution of neuroblastoma follows the sympathetico-adrenal lineage. And once again, you might be asking yourself, well, where did these cells come from? Who set up these ganglia? Where did they migrate from? And by now you probably know that they've migrated from the neural crest. So the neural crest sets up these colonies of ganglia, and the adrenal medulla, they're of neural crest origin, and then they receive their innervation and they differentiate appropriately. So it's really, and as we'll see in the next lecture, a neuroblastoma is really a tumor of the developing neural crest as it migrates and populates and forms these sympathetic ganglia and the adrenal medullary pheochromocytes, the adrenal medullary cells of the sympathetic nervous system. And I'll end the lecture here, and I'll continue to elaborate on that in the next video.